Hi, engineers. You sit down for a coding interview, but no arrays today. The interviewer draws a circle with two branches and says, "Walk me through binary trees." How do you think about them? How do you solve problems with them? Let's make this simple and memorable. So, let's learn binary trees. Today, we'll answer what a binary tree is, how to walk it, where it shows up in interviews, and how to think about common challenges without touching code. Short and clear. Let's rephrase it in plain English, so it really clicks. A binary tree is a bunch of connected nodes where each node can point to at most two children, left and right. The very top node is the root. A node with no children is a leaf. Depth means how many steps from the root down to a node. Height means how many steps from a node down to its deepest leaf. A subtree is just this node plus everything below it. Let's imagine this so we have a shared picture. Root A. A's left child is B. A's right child is C. B has two children, D on the left, E on the right. C has one right child, F. So when I say names in an order, you can hear what traversal I'm doing. How do we walk a tree? Think visit orders. Preorder means node, then left, then right. You meet the boss first, then visit the teams. On our tree, you'd say A, B, D, E, C, F. In order means left, node, right. Left team, then the boss, then right team. You'd say D, B, E, A, C, F. In a binary search tree, this order reads values in sorted order. Postorder means left, right, node. Teams first, boss last. You'd say D, E, B, F, C, A. Level order means floor by floor, BFS. You'd say A, then B and C, then D, E, F. Where do binary trees show up in interviews? Actually, everywhere. They're perfect for recursion practice and combined child results problems. Most tasks boil down to do something at this node, then go left and right, or get answers from left and right, then decide at this node. Common patterns you'll be asked about, no code needed. Max depth or height. What's the longest path from root to a leaf? Think children first, then current equals 1 plus max, left, right. Balance tree. Is every node's left/right height difference at most 1? While computing heights, if a gap bigger than 1 appears, it's not balanced. Validate BST. Does the whole tree obey left node, right? Don't just compare to the parent. Carry a valid min/max range down the tree. Bonus. Inorder of a BST must be strictly increasing. Path sum. Is there a root to leaf path that adds to a target? Carry the remaining target down. Only celebrate when you land on a leaf with 0 remaining. Lowest common ancestor. Where do two nodes' paths first meet? If one target lives left and the other lives right, the current node is their meeting point. Invert a tree. Mirror left and right everywhere. Great warm-up for tree thinking. Serialize/deserialize. Turn the tree into a sequence and back. Remember to record empty spots so you can rebuild shape, not just values. When do we use DFS versus BFS? Use DFS, pre, in, or post, when answers depend on full subtree info like heights, sums, structure checks. Use BFS, level order, when levels matter, shortest steps, grouping by depth or width. Tiny example runs in words so you can feel them. Say preorder on our B, C tree. A, B, D, E, C, F. That's decide first, then explore. Say inorder on a BST. It reads sorted numbers. Great for, is this a BST? Checks. Say postorder for height. You must know both children before you speak the parent's number. Children first, boss last. Pitfalls to avoid. Mixing depth and height definitions. Forgetting to handle missing children in your reasoning. Validating a BST using only the parent instead of a full range. Claiming path some success before you're at a leaf. Counting levels before you've actually finished a whole level in BFS. How to speak about this in an interview. First, clarify. Binary tree or BST. Balanced or arbitrary. Are values unique? Second, choose the traversal that fits the goal. Preorder for building or serializing. Inorder for BST logic. Postorder for children first results like height and balance. Level order for shortest path or level grouping. Third, state complexity out loud. Visiting in nodes is O, N. Extra space is O, H. For recursion depth or queue size for BFS, where H is height. Fourth, dry run the little A, B, C, D, E, F picture verbally in the chosen order. Fifth, close with one line. Most tree problems are visit node, visit children, then combine results. No code analogy to lock it in. Think of a company's org chart. CEO at the top. Each manager can have up to 2 direct reports. Preorder is meeting the manager before the teams. Inorder is left team, manager, right team, in a BST that magically lists people in sorted order. Postorder is finishing both teams before reporting to the manager. Level order is visiting the company floor by floor. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow at Code Crack Interviews.